Hello everybody, welcome into another lesson. So today we're going to talk about angles. And a little humor for you here. We spell it A-N-G-L-E. That's an angle. Don't spell it A-N-G-E-L, because then you're talking about an angel. So it's A-N-G-L-E for an angle. We aren't talking about angels in this course. So okay, so what is an angle? An angle has two rays that come together at a common endpoint. So we have ray BA, right? It starts at point B, goes through A, that's ray BA, meets also at point B with ray BC. Together, they have the same endpoint. They form what's called an angle. Now, you may see this referred to as one of two ways. This is the angle symbol when referring to an angle. You may see angle B, because sometimes it's just called by its vertex. It could be angle B, or you could actually see all 3 points named. This could be referred to as angle ABC. Either way, they refer to the same angle. So you also can name it by its 3 points or just simply the vertex. So that part was easy enough. Now something a little bit different here. What if here we had 3 rays, and they still all come together at the same endpoint, E, but you have ray ER, ray ES, and ray ET all starting from the same endpoint. This is still technically an angle, but inside this angle you have 2 sub-angles that make up the whole angle. So you could also, sometimes what's done, when you have sub-angles, they number them. You could call this angle 2, you could call this angle 3, you call it 1 or 2, you could call it 999, 1000, whatever you want. Sometimes they get numbered. So how you might see this referred to, if you just try to refer to angle E, they're not sure of, no one's going to be sure of which angle you're talking about, because there are a couple of angles here. So if you have more than one angle inside the angle, like if you have 2 or more sub-angles, you don't want to refer to it by the vertex. If it was just one angle, sure, refer to it by the vertex, that's fine. But whenever you have more than one angle, this is where you want to do one of 2 things. We have angle 2 right here. You can refer to it as angle 2. What else? If you're trying to refer to angle RES, you can refer to it as angle 2, or you can refer to it as angle RES. That would also work. And when referring to angles, the vertex is always in the middle. I know that's weird because when we talk about rays, the starting point's the first letter, but when it comes to angles, your vertex will always be in the middle. The vertex of the angle is simply where all the rays meet together to form the angle. That's the vertex. And then, let's see, SET we can refer to as angle 3 or angle SET. And then you can still refer to this as one giant angle, but since there's more than one angle, you don't just want to say angle E, you would want to say RET. So if you're referring to both angles put together, and to combine into one angle, you'll want to say angle RET. So that's how you would deal with more than one angle put together. Okay, so there's the basics on those angles. Now, let's see here. Let's talk about different types of angles. Let's start with one we should all be familiar with these by now. Let's see here. I'll call this angle 1. We'll put the point A, B, C. Okay. So this will be angle 1. Let's say I used a protractor and I measured this and I got a 45-degree angle. How would I write the measure of an angle? Well, it's going to be like naming an angle, but you would say the measure of angle 1 is equal to 45 degrees. Or you could say the measure of angle B is equal to 45 degrees. Or the measure of angle ABC is equal to 45 degrees. All three of these are naming the same angle. It's just simply how you're listing it. You could call it angle 1, you could call it angle B since there's only one angle, you could call it angle ABC and name it by its points. So that's how you would write what the measure of an angle is. Okay? Now, if the measure of the angle is less than 90 degrees, the angle is acute. So if you have an angle that's less than 90 degrees, it's called an acute angle. And you can remember it like, oh, it's so little, it's so acute. That's how you can remember that. So this is an example of an acute angle. Let's just say I used a protractor and I measured this and got 45 degrees. Now, let's talk about another type. See, point A will be here, B here, C here, and then let's see. So this is going to be a right angle, and often to denote a right angle, you'll put a little corner piece on the angle. You'll often see that to denote that it's a right angle. I mean, we could number it also, that would be fine, but I'm not going to in this case. So if the measure of the angle, whoops, I almost drew a less than sign. I don't want to do that. The measure of the angle equals 90 degrees. The angle is a right angle. So it's a right angle. Right can also be abbreviated RT. You'll see that a lot in geometry also, the RT. Especially when you're doing proofs and stuff, you want to tend to abbreviate things if you can, because it can be very long wording. But a 90-degree angle is a right angle. That's if and only if the angle equals 90 degrees itself. If it's even 89.9, it's an acute angle. If it's 90.1, anything greater than 90, we get into the next type called an obtuse angle, which is something different. We'll get to obtuse in a minute. But you can say that the measure of angle B is equal to 90 degrees, or the measure of angle ABC equals 90 degrees. Or if you want to, you can do CBA. You could even say the measure of angle CBA, as long as the vertex of the angle is in the middle, that's equal to 90 degrees. It doesn't matter which point you start from on the angle, as long as your vertex is in the middle. All three of these name the same angle, but a right angle is 90 degrees. I used my protractor and it turned out to be 90 degrees. Which now we're about to get into the obtuse angles. Here's A, here's B, here's C. We'll call this angle 1 also. We'll number it even. So if the measure of the angle is greater than 90 degrees but less than 180 degrees, the angle is obtuse. So an obtuse angle, like we're going to say with this one, I used a protractor and measured this angle and it turned out to be 120 degrees. So if the measure of an angle is greater than 90 degrees but it's less than 180 degrees, then you have what's called an obtuse angle. You can think of it as like obese, big, obtuse. That's how you can think of it. So in this one I determined as 120 degrees. We could say the measure of angle 1 equals 120 degrees. You could also say the measure of angle B equals 120 degrees. I could say the measure of angle ABC equals 120 degrees. Or I could say the measure of angle CBA equals 120 degrees. All four of these name the exact same angle. So that's an obtuse angle and what one looks like. Now, when we get into trigonometry, especially in the Algebra 2 trig side and pre-calculus, there are other ways of measuring angles, like radians. Some of you may have heard of radians, but we're not going to do radians in this course. In geometry, we're only going to stick with degrees. So that'll make life a lot easier. But in Algebra 2 trig and then in pre-calc, which comes after that, we'll not only be using degrees, we'll be using radians. Okay. Now let's talk about the final type of angle, which you're all probably also familiar with. Okay, so if the measure of the angle equals 180 degrees, which this one does, I took my protractor, this angle measured 180 degrees, then the angle is straight. You have what's called a straight angle if and only if the measure of the angle equals exactly 180 degrees. So that's a straight angle. You can think of it as your line straight down. When you lay down on a bed or something, you're at a 180 degree angle. Like me, standing straight up, I'm at a 90 degree angle. I make a 90 degree angle with the floor. But when I lay down in bed at night, I'm at a 180 degree angle. I'm laying straight down. So with this, I can say the measure of angle B equals 180 degrees. I could say the measure of angle ABC, because B is still the vertex, even though it's a straight line, a straight angle, B's the vertex of rays BA and BC. You still have two rays. It's just it looks weird because it's a straight line. But the measure of angle ABC, that's 180 degrees. Or you could say the measure of angle CBA equals 180 degrees. So that there is a straight angle, and that's so far now we've seen how to write the measure of an angle in geometric terms. Okay, I got a little bit more here. I got a couple more postulates today to share with you. So let's see here. All right, let's see. Let's draw this out here. Yeah, right. Just bear with me a minute while I draw it. I gotta draw a nice diagram here. You know what? Let's do this for this next one. Okay, so I got a nice diagram here, which I will explain shortly. But this postulate here that I'm about to share with you is called the protractor postulate. We have here what is called the protractor postulate, which I'm just going to abbreviate it post with a period. And this one we don't use a whole lot, but I still have to teach it. So, okay, this states that on line AB, in a given plane, choose any point O. Yeah, I'm going to take up a lot of board space here. Between A and B. So let's stop there for a second. I'll give everyone a chance to catch up if you're writing this down, but so we have a line AB here, right, at the very bottom of this diagram. It's in a given plane. A line's always in a plane. You choose any point O, which we have here, between points A and B. So we see that so far, right? Okay, so we're there so far. Consider ray OA and ray OB and all rays that can be drawn from O on one side of line AB. I'll pause here for a second while everyone's catching up in case you're writing this down. Okay, so we've talked about the first part with the line. Now consider rays OA, because it starts at O, goes through A. We have a ray there. And then consider ray OB, starts at O, goes through B. We have a ray here. And all rays that can be drawn from O on one side of line AB. So X here, this is going to be an angle measure, so is Y, okay? We'll get to the angle measure in a second. We'll deal with that in a second, but we're going to consider all rays that can be drawn from point O, which we have ray OP right here, and we have ray OQ right here. So we can, and I can actually draw infinitely more rays if I wanted to, but I don't see a need to do that. We're only talking about two more in particular. Alright, but they're drawn on one side of AB, as it says. So these rays can be paired with real numbers from 0 to 180 in such a way that, and there's two subparts to this, but this is the main body of the postulate here. Well, let's see, ray OA, that's definitely going to equal a 0-degree angle, right? Ray OA, this forms a 0-degree angle. If you go back to ray OB, so angle BOA, this would form a 180-degree angle. So for the final part, these rays can be paired with real numbers from 0 to 180 in such a way that ray OA, that's just a 0-degree angle. Ray OB, you're taking this all the way back. This is paired with a 180-degree angle. So it's obvious that X and Y are somewhere in between 0 and 180, right? Okay, everyone's catching this up here. I'm going to do the subparts in a second. So let me read the whole theorem. On line AB in a given plane, choose any point 0 between A and B. So we have a line AB right here. We have a point O that occurs between A and B. We've met that. Consider ray OA and ray OB in all rays that can be drawn from O on one side of line AB, which we've done here. These rays can be paired with real numbers from 0 to 180 in such a way that, okay, OA is paired with 0, B is paired with 180. We don't know X, we don't know Y, we don't really need to at this point, because this is just an overall postulate. But the idea is here we're mimicking a protractor, basically. That's really what the whole idea is. Alright, I'm going to figure everyone got that by now, so I'm going to do the two subparts. I'll erase this a little bit slowly so everyone can catch up what they're trying to do here. This is kind of a big postulate, so I understand. if you're deciding to write this down. I would highly encourage you to. You don't have to, because I have no way to give you guys tests in here. I can just hope you're learning from it, but this is supplementary anyway to what you actually take in high school or college. This is supplementary, so alright, I think everyone's got it by now. Okay, let's go on to the two subparts. Part A, ray OA is paired with 0 degrees. Ray OB is paired with 180 degrees. Okay, so we've already kind of talked about that for this subpart A. There's a subpart B, and that's about it to this postulate. But we see ray OA is paired with 0 degrees, ray OB is paired with 180 degrees. So I think that part's pretty self-explanatory. Alright, everyone got this? I'm going to talk about part B in a second. I'll tell you what, I'll let you write that down. Let me get a sip of coffee real quick. Alright. I figure everyone got that by now. And I do apologize for longer lessons than in algebra and stuff, but geometry is a lot to unpack. It really is. What may seem like a simple lesson to the negative eye really has a lot of context to it and things that we got to cover. Okay. Part 2 is if ray OP, so here's OP, is paired with X, and ray OQ is paired with Y. So yes, we see ray OP is paired with X. Then we see ray OQ is paired with Y. So we've seen that so far. Then the measure of angle POQ is equal to the absolute value of X minus Y. Okay, so we've talked about the rays. So if ray OP is paired with X and ray OQ is paired with Y, then the measure of angle POQ is equal to the absolute value of X minus Y. You'll get an answer like that in degrees. Okay, so I'll let everyone catch that part up. Now let's go ahead and put this into practice here. I'll throw in a couple values here. We'll demonstrate this with the protractor postulate. You don't often use it in proof, but you do use it in practice when you're doing actual math problems with this, if that makes sense. So that's why this is important to learn. Alright, so let's say this is 30 degrees here, right? We can pair, no, that looks more like a 45 degree angle. That looks like a 45 degree angle. I'm going to say this could be paired with 135 degrees. So that's how you would actually see this in practice. Ray OP, so this is paired with 45 degrees. Ray OQ is paired with 135 degrees, okay? So the whole thing being 135 degrees. Well, we want to find just the measure of angle POQ. Just POQ. So how we're going to do that here, let me write in black so you can see it better. The measure of angle POQ is going to be equal to the absolute value of this 45 degrees minus 135 degrees. Right? Okay. Well, what is 45 minus 135? That's negative 90. So this is equal to the absolute value of negative 90 degrees, which we know the absolute value of negative 90 is positive 90. So the measure of angle POQ in this case is equal to 90 degrees. So that's the protractor postulate at work. You just take the value of the one angle, subtract it from the value of the other angle, the absolute value of that, and you'll get the value of the angle you're looking for. So the protractor postulate was a lot of big wording. I realized that, and I realized it was kind of a pain to write if you were doing it, but it's actually fairly simple to understand. Okay, I do have another postulate here, which is a lot easier than the one we just did. Let's see, I'm going to demonstrate with a couple of cases here. So let's form an angle. C, B, and A. Okay. So we could argue there's three angles. You have two subangles and then you have one whole angle. So you have rays OC, rays OB, rays OA. They all form angles BOA, COB, and COA, right? Okay. Well, what we're about to talk about here, which I think we sort of touched on, but not quite. This is called the Angle Addition Postulate. We're going to talk about the Angle Addition Postulate. Alright. This one's going to seem like a lot of common sense, to be honest. So if point B, which is right here, lies in the interior of angle AOC, which it does. Point B lies in the interior of angle AOC. Okay, we've established that. Then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Alright, so to sum this up, if point B lies in the interior of angle AOC, as we see here, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So basically, if you add these two angles together, you'll get the measure of the entire angle. That's all that states. The angle addition postulate. Seems pretty simple, right? There's one more example with this. It's kind of similar, but a little bit different. This is the second part of the postulate. So this one wasn't too bad. It seems like pretty much common sense, doesn't it? This time, let's see, we have, now let's go a little lower. I don't like it up so high, so you can actually see the drawing a little bit more. Alright, here's A, here's O, here's C, and then right here we have point B. Okay. So this time, let's see, we have rays OA, rays OC, and rays OB. Notice about line AOC. Basically, ray OA, this would correspond to 180 degrees, right? Well, we know angle BOC and BOA, those are two subangles of this straight angle. It clearly looks like BOC would be an obtuse angle. And then if you add the acute angle of BOA, you would get 180 degrees. Well, this next part states just that. So, if angle AOC is a straight angle, I'm just going to abbreviate angle there at the symbol. It'd help if I spelled straight right, wouldn't it? I know this is an English class, but I still like to spell right because this is educational. I don't want to teach you wrong. Whoops, we don't need the comma there. And B is any given point not on line AC then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Okay, so if angle AOC, which this is a straight angle, we're just referring to the entire thing being a straight angle, and B is any given point that's not on line AC, well, clearly it's not on line AC, it lies on ray OB, which is outside of line AC, then the measure of angle AOB plus the measure of angle BOC equals, this should say 180. It's true it equals angle AOC, that's true. But basically the sum of these two angles together would equal 180 degrees. That's all that's saying. So you have two angles together that would equal 180 degrees. So, seems pretty obvious, right? This wasn't too bad of a postulate to do. Alright, so. And then we got to talk about congruent angles. Alright, so congruent angles are angles that have the same measure. So we'll talk about congruent angles. Here's how you would write angles plural in abbreviation, angle with a little s inside of it. So congruent angles, let's demonstrate here. Let's say angle 1, this is 45 degrees. I draw an angle 2 next to it. that's also 45 degrees, you have congruent angles, right? Just like yesterday we talked about congruent segments and congruent figures, you also have congruent angles. Congruent means that they're the exact same size. In this case, the measure of angle 1 equals 45, the measure of angle 2 also equals 45. So a couple ways to say this. You could say angle 1 is congruent to angle 2. There's the congruent symbol again. Or what you can say is the measure of angle 1 equals the measure of angle 2. Remember, congruent and equal are basically interchangeable. They mean the same thing. So you could say angle 1 is congruent to angle 2, or the measure of angle 1 equals the measure of angle 2. That's how you could deal with congruent angles. Alright, then we need to talk about adjacent angles. Let's talk about adjacent angles. So, adjacent angles now. So, let's do this. See, we have angle 1 here, angle 2 here. So when we think of adjacent angles, they are two angles in a plane that have a common vertex. Well, angle 2 has this vertex, angle 1 also has this vertex. They share the same vertex, right? So you could say angle 1 is adjacent to angle 2. Angle 1 is adjacent to angle 2 since they have the same vertex and they're next to each other. They have adjacent angles, have the same vertex. What else? They have a common side. Angle 2 and angle 1 both have this middle ray as a common side, right? But they have no common endpoints. Like, this ray would have no common endpoints with that one, right? So, it'd probably help if I put some letters on this. Okay, so, like ray DB, so point B, ray DB is a common side of angle 1 and it's a common side of angle 2. They have a common side, and they have the common vertex of D, so far these are adjacent angles. Angle 1 and angle 2 are adjacent. But they have no common interior points. Like, for example, we have DA, ray DA, point A is not common with point C, so that's how you would determine them as separate angles, but they're adjacent because they share ray DB, they share point B, but that's about it, and they're right next to each other. Now, let's talk about some other angles here that are not adjacent. Okay, so the question is here, are angle 3 and angle 4 adjacent angles? Well, let's go through a checklist. Do they all have the same vertex? They do have the same vertex, point O. That's true. But here's the problem. So angle 4 has ray OB and ray OA. Angle 3 has ray OD and ray OC. They have no common sides that they share, right? So these are not adjacent angles. In order to have adjacent angles, both the common vertex and sharing a common side must be present. They may have the same vertex, but they have no common interior sides, right? They have no common interior sides. So these would not be adjacent angles. How about this one? We have angles 1 and angle 2. Well, they both have a common vertex, right? They sure do. And they even share a common side, this ray right here. Both the criteria are present, so angle 1 is adjacent to angle 2. You could say angle 1 is adjacent to angle 2 since they have the same vertex and they share a common side, which is this ray right here. So they have to have the common vertex and the common side. If either one of those criteria is missing, then you don't have adjacent angles. It's really that simple. Here's a trick one. I'm going to give you a bit of a trick one here that tends to get people. So let's see. Sometimes you'll see an angle denoted with a line with kind of a curve. This small one here is 3. This whole thing is going to be 4 for the big angle. The question is, I'm going to write it here, is angle 3 adjacent to angle 4? Are these two angles adjacent? Well, angle 3 is just this small sub-angle here on the lower part, on the lower angle of this whole thing. Angle 4 is the whole angle. Are they adjacent angles? Well, we know they all share a common vertex, right? That part's present. Angle 3, alright, they do have it has this side in common. I mean, it would seem like they have both sides in common, right? It would seem like they have a common side with this bottom piece. But angle 4, what it does not have in common is this middle side. It does not have this this middle ray. So these are actually not adjacent angles. These are not adjacent angles for the fact that they don't have the middle piece in common. Angle 3 is a subangle of angle 4, granted, and it has the middle ray, but angle 4 doesn't contain the middle ray at all. If you have one angle that's a subangle of the whole thing, like angle 4, then it's not going to be an adjacent angle. It's simply a subangle. It's not an adjacent angle. So that's a case where it may seem like an adjacent angle, but it's not. And then we need to talk about the bisector of an angle. Alright, bisector of an angle, or you could say angle bisector. Or you could just say angle bis with a period. that's how you would abbreviate angle bisector. So let me draw, that's not the best right angle I could draw, is it? Let me draw a right angle here with another ray. So let's see, I'll call this point A, this will be point O, this will be point B, that'll be point C. Okay, so what is an angle bisector? Well, remember, to bisect means to split it into two even pieces. The bisector of an angle is nothing more than a ray that splits the angle into two equal pieces. So the measure of angle AOB, which is this entire thing right here, the whole master angle is equal to 90 degrees, right? Well, if ray OC bisects the angle, it bisects it perfectly, I'm going to get two 45-degree angles, am I not? I'll end up getting two 45-degree angles, which when you add them together, you would get the sum of the whole thing being 90 degrees. So on the bisector part, this would turn the measure of angle COB into 45 degrees. This would turn the measure of angle AOC also being 45 degrees, right? So AOC, COB. And together, if I add these together, the measure of angle COB plus the measure of angle AOC, that's going to equal the measure of angle AOB, which would equal 90 degrees. So that's the bisector of an angle. So you can also state that when you have angles bisected, okay, you can state here that the measure of angle COB is equal to the measure of angle AOC, right? Because it splits them into two separate angles. Or you could say angle COB is congruent to angle AOC. That's another way you can write it. Because after all, bisector splits into two congruent angles. You can also say that ray OC bisects, just abbreviate it, bisects angle AOB. That's another thing you can write. Ray OC bisects angle AOB. So that's really about it for today, talking about angle bisectors and all that stuff. The next lesson we are going to talk about postulates and theorems relating to points, lines, and planes. We'll throw in our very first theorems. We're going to get a bunch of postulates, but they're short ones, so they won't be bad. Then we're going to get 3 theorems to learn. So I hope everybody has a good day. Take care.